For the last few weeks, I've been working on printing and assembling the latest edition of the ERCF, or Enraged Rabbit Carrot Feeder. It's basically an open source multimaterial switcher akin to a Bambu Lab AMS or a Prusa MMU, but it prints 8 to 12 colors or materials, and it's printer-agnostic, meaning that you can install it on any printer running Klipper and turn that printer into a magnificent multicolor machine. I'm not quite there yet, as you can probably see, and I'll get into why that is in a little bit. But throughout the course of building this thing on live streams, it's really come to my attention just how little people in the community actually know about this incredible open source project, especially compared to the more popular Voron project that it's loosely associated with. So I really wanted to just do a video to explain a bit about this system and this project, how it works, what's involved, and so on, and do that while it's still sitting on the table and we can kind of look under the hood. Plus, look around. I really don't know how much longer it is going to take to get this thing running perfectly, and I can't exactly create any other content until this printer and all these tools are no longer taking up my entire studio. So let's do it. Oh, and by the way, if you're new here, this channel is all about helping you get more out of this wonderful hobby that is 3D printing, whether that means product news or tutorials, ideas for what to print next. So if you love 3D printing as much as I do and you want to learn more about it, then don't forget to preheat that subscribe button. All right, so I explained really quickly in the intro just what the ERCF is, but considering that some people have never even heard of the project until now, let's take just a quick moment to explore the project and its history, and you can use the chapters below if you want to skip around. So the Enraged Rabbit project is, as I said, a fully open source multi-material switcher similar to the Prusa MMU. It's the result of a lot of hard work and amazing collaboration between many different people, far too many people to list in this video, but some of the key figures include Edigit, GNU, Sneaky Tree Snake, Magi, Kinematic Digit, Miriax, and Fragmon. I actually wasn't able to find out when the first versions of it came out or when development started, but version 1.1 has been publicly available since June of 2021. In those 3 years, a really lively ecosystem has really cropped up around this project with a variety of certified, fully sourced kits from numerous manufacturers, dozens of different upgrades and customizations, and really a thriving community of super helpful people in the related channels on the Voron Discord, many of whom have been really awesome in helping me diagnose the issues as I go along, so thank you. Oh, and as if you even had to ask, yes, this is a fully do-it-yourself project. There are kits available like this one to make sourcing easy, but much like the Voron printers that they're associated with, you cannot buy a fully assembled version of this, and you'll understand why in a minute. Now, one of the other questions that a lot of people asked me during my live streams was just how this thing works. So let's take a moment. It can be a little bit confusing, and before it's actually mounted on the printer and all set up, let's take a moment and just examine it and its functionality while we can, like I said, look under the hood. For now, you can ignore this big thing hiding on the back. We'll actually get to that in a second. Now, the ERCF itself, at its core, is a motion system consisting of just 2 stepper motors. One of them, the selector motor, drives this selector up and down these smooth rods. Get your heads out of the gutter, people. And it positions the selector in the right position for the filament that you need to use at that point in the print. Then, once it's in position, a servo right in the middle smashes down on these cartridge thingies, or filament block in ERCF speak, which are magnetically hovering over it and separated. So when it mashes down on the blocks, it's actually mashing down on a Bondtech gear and pushing it towards another Bondtech gear on the bottom. It's basically smashing them and creating a gear sandwich around the filament. That way, when the main motor actually turns, it will actually catch and push one of the filaments, whichever one is currently selected in the block. Now, I think the part that confuses people is that the actual drive shaft is running the entire length of the unit, and when it turns, it's of course turning in its entirety, as are all of the bottom gears. It's just that that doesn't do anything because all of the top gears are floating, so there's no smash. There's also a very clever little PCB right inside here with an encoder, which detects the filament moving so that the whole system knows just how far the filament has moved forward or back. Though, to be honest, I'm actually not sure why that's relevant because you do have individual little micro switches and sensors in each of the cartridges and in the tool head to know when the filament reaches or runs out at any of those locations. So I'm still figuring this out myself, and I'm just sharing what I've learned so far, like I said. Anyways, when you're done with that specific filament, the drive motor then slurps it back up Lady and the Tramp style, and the selector moves to the next filament in the print and sends that out. It's all probably very familiar to any of you who've seen really any other AMS system in operation. Speaking of different AMS systems, let's talk about the major differences between version 1.1, which came out in 2021, and this new one, version 2, which came out in late December of 2023. Now, I actually built this version 1.1 kit that was also provided by Physek, and I was in the process of configuring it when I damaged the Binky PCB, which is honestly something that I tend to do a lot. But while I was actually waiting for the replacement parts in the mail, version 2 actually came out. So I kind of just decided to put everything on hold until Physek sent me the new version 2 to try out. I mention that because I'm not really qualified to talk about the actual user experience and day-to-day experience besides what people have told me, but I do feel qualified to at least talk about the mechanical side and the build experience and the design differences at a really, really high level. So first and foremost, the obvious thing that you're going to notice is the difference that this one has this monstrous thing on the back, the Enraged Rabbit Carrot tail. And yes, everything in the ERCF multiverse has its own Enraged Rabbit name. There's the Enraged Rabbit Filametrix, the Enraged Rabbit Easybird, the Enraged Rabbit Filamentalist, the Enraged Rabbit Encoder Cutter. It's like a whole freaking thing, but I digress. The Enraged Rabbit Cottontail, that's the name for this buffer, is basically a buffer system that sits on the back and deals with the slack filament when it's retracted. Partly to prevent tangles, but largely, I'm told, to minimize drag on the filament and make filament swaps more reliable. Now, in the past, with that ERCF v1.1, there were a few different systems out there that people were using, ranging from Girari's auto-spooling filament holders for the rep rack, which I printed out in another video, but ended up removing the springs from because they didn't quite work for me, to other types of buffers and much, much more. With the ERCF2, the Cottontail is still optional, but it has become kind of one of the standard and accepted recommended upgrades, kind of like how Clicky is now included as a default in many Voron kits, and it's kind of considered part of the build. There are other options, of course, like the Filamentalist and some others I'll talk about in a second, but the ERCT is kind of the default option, and despite how much filament it uses or doesn't use, it definitely seems like you should start from here. Another obvious difference is going to be all of these LEDs and electronics. While both 1.1 and 2 run on one of a variety of different types of boards, such as the Enraged Rabbit board or Easybird, depending on which manufacturer you end up going with, version 2 has a lot more smarts. It includes individual micro switches that act as filament sensors in each one of the blocks, as well as fancy pants LEDs in the front and the back, at least in this Physek kit, that will let you know from either side you look at which blocks are loaded and which ones are not. But I think it's probably two of the least flashy and noticeable upgrades that are going to make the biggest difference in the actual build and user experience with version 2. The first is the 2020 aluminum extrusion that the entire thing is built on, and you actually mount everything to it. Now, as you can see from the version 1.1, in this one, all the plastic parts were just bolted together, and it made it much more rickety and just partial to being crooked. The use of an aluminum extrusion here makes this thing much, much more solid, so much so that you actually can just sit it on top of the acrylic panels on your printer without needing to mount it to the printer's extrusion for stability. The second of the less obvious upgrades is the integration of yet another optional but highly recommended upgrade, which is the Filametrix filament cutter. This cutter, which I have to assume is really heavily inspired by Bambu Lab, cuts the filament right at the toolhead, eliminating the need for what ERCF users call tip tuning. Now, I never had to do this or never bothered to, but from what I've been told, this was one of the biggest hassles of using the version 1.1. Basically tuning the retraction speed to get the absolute perfect tip at the end of the filament to prevent clogs or wisps in the Bowden tubes. This apparently took people hours, days, or weeks of tinkering and tuning, and I don't know about you, but that is a lot of effort for just the tip. Now, it's worth noting that this is still technically optional, and as seems to always be the case with the ERCF and the Vorons in general, there are many other community-generated options out there to solve this problem. For example, the Enraged Rabbit encoder cutter, which, as the name implies, actually cuts the filament right here at the encoder instead of needing to purge the filament from the hot end. There's also the Blobifier mod, which will turn the filament into blobs instead of poops. And it can honestly be super overwhelming to decide which of all these upgrades you actually want to do. So generally, I like to stick to the kind of mainline recommended upgrades that are included with my kit, just like I did with each of my Vorons. And then I only branch out after I have things working well enough. It might seem like wasting a bunch of filament and time installing stuff you're going to take off, but it makes it a lot easier to get help from others when you need it. Another thing I want to point out is that unlike closed source systems like the Bambu Lab AMS or AMS Lite, you can take full control of this system in both hardware and software, meaning that you can actually tune it to retract the absolute maximum amount of filament before cutting off the tip, which should lead to significantly lower waste than some of the other systems because you're only purging the very tip. And yes, 2 just the tip jokes are too much for this video. By the way, the differences between 1.1 and version 2 and all the different upgrade options is something that I did talk about at length in my podcast episode with Ivan Trail, who's an official member of the ERCF team. So I will link to that interview somewhere up here and in the video description, and I recommend you check it out if you're interested in all of this. Up next, we're going to talk about the actual build experience, but first I would love to take a moment to thank this video's sponsor, which is PCBWay. Whether it's custom PCBs like the one used in this kit, or 3D printed metal, sheet metal, injection molding, CNC'd parts, laser cut parts, or just about any other industrial manufacturing process, PCBWay has you covered. I've used PCBWay for a lot of my recent projects, ranging from my SV08 Revo adapter to various parts on my ongoing and never-ending filament recycling project, and much, much more. And honestly, I'm always blown away by the quality and the customer service that I get from PCBWay. As a new customer, you do get $5 off your first order, so do check it out using the link in the description. And thank you guys for supporting the sponsors who support me and make all these videos possible. All right, let's get back to the video. Now, at this point, if you like what you've heard so far, you're probably wondering, what does it take to actually build this thing? Well, personally, I have built a Prusa Mark IIIs Plus, a Voron 2.4, I've helped build 2 Voron 0.2s that I did on live streams, and I built the ERCF 1.1. So I'm pretty comfortable and experienced with these types of complex builds. With that said, it did take me about 16 hours across 3 grueling live streams conducted over 2 absolutely exhausting days to actually build this thing. I'm pretty sure that if I hadn't been concerned with also entertaining an audience and recording B-roll all at the same time, I probably could have done it in less. And of course, the 8-color version is going to be a lot less work than this 12-color one. But still, I don't think anyone is building any version of this in less than like 12 hours. And I definitely don't recommend doing them back to back. Also, that doesn't include all the time to sit down, lay out the build plates, slice the files, print them, swap the build plates, reprint any failed parts. Oh, and in case you are wondering, I don't actually know how many print hours this was, but the parts weighed in at 2.36 kilos with the bin. So about 1.65 kilos of plastic, which according to ChatGPT, that's somewhere between 40 and 100 hours, but ChatGPT really sucks at math, so honestly, who knows? As far as the actual build, like building a Voron, nothing about it is particularly difficult. At times, repeating the same thing can be a little bit tedious, but at other times, it's actually super satisfying to get better at it and snap the parts into place in like a little assembly line. Overall, I really honestly enjoyed the build, and I think that you will too, if you're the type of person who likes assembling things like printers, and if you don't subject yourself to a marathon of live streams over 2 days like I did. Yes, there were a few tricky or annoying parts, such as a couple of wires being a little bit too short, or needing to actually thread the cables through the chain because this cable chain doesn't open up in the bottom. Stuff like that, but mostly it is a lot of fun. Now, if you want, you actually can watch the 16 hours of live streams for a full play-by-play install guide, but I honestly can't imagine why anyone in their right mind would do that. I would say, though, that if you haven't already built something like a very complex build, something like a Voron or even a Prusa machine, the ERCF is probably not a good first entry point into these types of long builds. Yes, you technically could pick up a ready-made off-the-shelf Klipper printer like an SVO7 or a Creality Ender 3 V3 KE, and you could get the ERCF to work with it. And yes, I am sure that you'd probably be able to figure out. The instructions are really, really clear, almost perfect, honestly. But I still really think that the reason that you only see these units on custom printers like Vorons is because it is an intermediate or even an advanced level build. And unless you already have a lot of experience under your belt building stuff and working with 3D printers or some other hobby like working on cars, I personally don't think that you're going to have a very good time building this, and that's before you get to the actually really crappy parts. See, the part that kind of sucks, at least for me, is the whole electronics, firmware, software, and all of that. But to be honest, I do always hate that on every single printer build, so you might actually love it. Now, I'll concede we are lucky in that ERCF kits today ship with these ready-made motherboards to connect everything. So wiring it up is honestly a cinch. And we're also very lucky that we get the Happy Hair software, which is this comprehensive software tool for managing the ERCF and other open source MMUs like the TradRack. And it controls the entire thing and gives you macros and all of that. The Happy Hair is fairly easy to set up. It has a wizard that auto configures itself. But of course, it's not perfect, and you'll probably still run into some issues either flashing the firmware or changing config stuff or just getting all the different boards to talk to one another. But as I said, people speak very highly of Happy Hair, and the software stuff is always something that I personally dread, so I'm definitely not a good indication or barometer of how approachable it actually is. Now, I've been told that the Happy Hair, in addition to controlling your MMU in the Klipper web interface, will also interface with the multicolor features of Orca Slicer and much, much more. Unfortunately, right now, I can't actually show you all that in this video because the printer, as you can see, is not running at the moment. And that's actually a good segue into why this printer is still not running and why I'm putting this video out now instead of when it's done. Now, I actually did manage to get things working, at least software-wise, and I was in the process of working through all the kind of fine-tuning, getting the servo to go to the right amount and grip the filament the right amount and all that. But it was at that point that I decided to shift focus and start working on rebuilding the entire toolhead. As I mentioned before, the ERCF V2 strongly recommends adding a filament cutter and a toolhead filament sensor into the mix at the same time, rather than having to deal with all the tip tuning stuff. In order to do that, I was going to have to upgrade the actual toolhead board that was on my printer to add an additional end stop slot. Between that and all the different modified parts that I would need for the Filametrics filament cutter, I decided to just rebuild the entire Stealth Burner toolhead and convert it to CAN bus, using most of the parts from a Stealth Burner kit that Physek also kindly provided. Then I also added a combination of the Big Tree Tech EBB36 and U2C CAN bus boards. Unfortunately, I wasted the better part of yesterday trying to crimp connectors, remove old wiring harnesses, run new wiring, and making stupid mistakes with my voltmeter, thinking I had a short, but actually my voltmeter was just not configured properly. And by the way, I love Big Tree Tech. They're amazing people with amazing products. But as it stands right now, the documentation for the UTC and the EBB36 is just not super awesome or up to date. And some of the amazing guides that other creators have already made are actually no longer up to date at the time of this recording because they've been updating the software, to their credit. I did, however, manage to get everything wired up, wiring-wise, and powered on with no magic smoke. So hopefully today or tomorrow after I record this, I'm going to either get some help from Big Tree Tech themselves or the Voron Discord or my patron Jacques, who was very kind to actually come over and spend an entire day helping me and playing Hacker Man.
I'm in.
So that I could try and figure this out. One way or another, I'll eventually figure this out and figure out how I can get the Big Tree Tech Octopus to communicate through the U2C CAN bus board simultaneously to both the ERCF, ERB, and the EBB36. It is ridiculous to speak in all these acronyms, and if that sounds confusing to all of you, know that I only barely understand it myself. But I really don't have a choice because I already ripped out the original cable chain and wiring harness and all of that stuff, so it's really a kind of burn the ships Vasco da Gama kind of thing, obviously without all the atrocities. By my next video, I really hope to have some epic 12 color prints to show off to all of you, and maybe I can even do a whole video comparing the different experiences and print quality between this multicolor system, the Bambu Lab AMS Lite, the normal Bambu Lab AMS, and even the Anycubic Ace, because I think I'm probably one of the few people that have all 4 of them in my hands. Either way, I really got to get this project done right now because number one, I cannot afford another on-hold project taking up space, but number 2, I really need my studio back. This is actually taking up set A, set B, and I have no printer in the background in set C, so this literally was the only video I could record this week. Also, another reason I have to get this done, and spoiler alert, I have recently committed to building a custom 7-tool changer Sovol SV08 after this whole project is done. So do get subscribed if you want updates on this and that and the other thing. And consider checking out our Patreon if you want more frequent and behind-the-scenes updates to all my projects, access to my printer and filament profiles, exclusive discounts that all but pay for your entire membership, and much, much more. That's all for this week, but I'll see all of you on the next layer.